Okay, good morning, all of you. Welcome to Laksha Academy. Okay, this is the 15th part of excretory products and their elimination. Okay, in the previous video, I covered reabsorption and secretion in the PCT proximal convoluted tube. In the next part is Henle's loop or loop of Henle. Okay, can you tell me what are the three parts of Henle's loop? It is a descending limb and ascending limb. Ascending limb has a two-part thin segment and thick segment. Okay, this loop of Henle, okay, very important for the formation of concentrated urine. Okay, our urine osmolarity is 1200 milliosmoles, whereas our blood osmolarity is 300 milliosmoles. Now I am comparing our urine and blood. Okay, compared to blood, the osmolarity of urine is more. That's why I'm using the term hypertonic urine. Blood is hypotonic compared to urine. For the formation of this hypertonic urine, okay, Henle's loop play an important role. Okay, what would happen if Henle's loop is not present? It was a bit asked in the previous NEET exam. Okay, if Henle's loop were absent, okay, that would lead to the formation of dilute urine instead of concentrated urine. Reabsorption in this segment Reabsorption in this segment is minimum, but this region Henle's loop plays significant role in the maintenance of high osmolarity of the medullary interstitial fluid. Look, in the kidney, there is a cortex and medulla. In the medulla, osmolarity of the interstitial fluid, tissue fluid, interstitial fluid osmolarity 1200 milliosmoles in this part. How that 1200 milliosmoles is maintained? In maintaining the 1200 milliosmoles of osmolarity, okay, this Henle's loop plays an important role. Okay, that osmolarity is the what is meant by osmolarity. I told you in the previous part also. Osmolarity is the measure of solute concentration. Measure of solute concentration. So if you take one solution, how much solute is present, that measurement of solute concentration in a solution is called as osmolarity. Okay, defined as the number of osmoles of solute per liter of solution. It is denoted as OSMol, osmoles per liter, or OSM, osmol liter. The descending limb of loop of Henle is permeable to water. You can see here, this is the descending limb of loop of Henle, which is permeable to water, and it is permeable to solutes. Quite opposite. It is permeable to solvent. It is permeable to solutes. It is impermeable to water. It is impermeable to almost impermeable to electrolytes. I repeat again. It was asked in the previous NEET exam. This point. Okay, the descending limb of Henle's loop is permeable to solvent, that means water, impermeable to solutes like Na plus, K plus, Cl minus. On the other hand, the ascending limb of Henle's loop, thin segment as well as thick segment, are impermeable to water, that means solvent, and permeable to solutes, that means Na plus, K plus, and Cl minus. They are permeable. That's why they are going out. It is giving permission because there are some channels are here. Sodium, potassium, chlorine channels are present. They allow them to go outside. Okay, that's the point here. The descending limb of Henle's loop is permeable to water and almost impermeable to electrolytes. Obligatory reabsorption of water continues as the filtrate moves along the descending limb. Obligatory reabsorption, mandatory reabsorption. I told you in the previous part, mandatory reabsorption takes place in these two parts, descending limb of Henle's loop as well as in the PCT. It continues descending obligatory reabsorption of water. You can observe here, obligatory reabsorption of water continues as the filtrate moving down, as it is moving down, okay, along the water descending limb. As a result, the filtrate concentration gradually increases as it moves towards the inner medulla. Okay, the filter, what happens here, Okay, the filtrate concentration increases. I will show you here. Okay, when the filtrate is formed here, when the filtrate is formed here, the osmolarity is 300 milliosmoles. That is isotonic to our blood. I told you our blood osmolarity is 300. Here the filtrate osmolarity is also 300. That means both are isotonic. Compared these both are isotonic. That means it is isotonic compared to blood. But as it moves down, what happened, what is coming outside? Solvent. That means here NaCl, so many electrolytes are there, their concentration is increasing as the solvent is coming. For example, you have taken water in a beaker, you kept that salt solution in a beaker in a sunlight. What will happen? When you keep it in sunlight, water evaporate. Water means solvent. That means the solute concentration increases as the solvent, okay, evaporates. That means osmolarity of that salt solution that you kept in the sunlight increases. Same thing happening here. You kept this part in the sunlight, water is evaporating, and therefore solute concentration is increasing. Osmolarity is the number of solutes, number of molecules. So you can see here what is osmolarity. It is as the number of osmoles per solute, number of osmoles of solute per liter solution. Okay, that means the osmoles number increases, therefore osmolarity of that water that you kept in sunlight increases. Okay, that happens, that is happening. That means that's why the filtrate here becoming higher osmolar, 1200 milliosmoles the filtrate osmolarity when it reaches the this part. Okay, permeable to water, obligatory reabsorption of water takes place. As a result, the filtrate concentration gradually increases as it moves towards the inner medulla. Why water is coming out? Because the reason is that here in the medulla, there is this NaCl outside here. How is this NaCl present here? This NaCl is coming from this side. NaCl is coming from the DCT. Sorry. Okay, it is coming from the descending limb, ascending limb. Sorry, ascending limb. As the NaCl is coming outside, that NaCl draws water. Why water is coming? Because NaCl is attracting water. That's why. That is the reason why water is coming out. As the water is coming down, it here the osmolarity increases. Okay, next one, the ascending limb is impermeable to water. This is impermeable to water. It does not allow the water to go out. In the proximal thin segment of ascending limb, NaCl diffuses out passively. Here NaCl is coming out. It occurs without any expenditure of energy. It occurs passively. Another important point. In the distal thick segment, this is the distal thick segment. This is a thick segment. You can see here, this is the thin segment of the ascending limb. This is a thick segment. Here also NaCl coming, but it is through active absorption. Okay, actively. It was also asked in previous exams. Very important. The filtrate becomes progressively more dilute as it moves up in the ascending limb towards the DCT. Okay, what is happening? Observe here. Okay, here the osmolarity of this filtrate is 1200. Now it has become 12. Okay, now it has become 700, here 400, here 200, and finally it has become here 100. 100, that means it is a hypo to our blood. Hypo, our blood osmolarity 300, but it is 1. But here what is happening? As it going upside, osmolarity, is it increasing or decreasing? Why osmolarity decreasing here? Can you guess it? Because what is coming out? Solute coming out. Solute coming out. As a solute is decreasing, osmolarity also decreasing. Osmolarity also decreasing as it moves, as it heads towards the DCT. Okay, that's that those are the things that take place in the, okay, this part in the Henle's loop.